Scholars, hi. Just a quick example of how to graph systems of linear inequalities. We just simply graph each inequality and then we take the intersection where all the regions meet. Um, let's see if I can do this one. X plus y less than or equal to 16, 3x plus 6y less than or equal to 60, x greater than or equal to 0, y greater than or equal to 0. One at a time, let me start with the first inequality. By the way, I'm going to try to do it displaying the scale is 5, every 5. If we tick mark will be 5 just due to the numbers. Okay, so the first inequality, x plus y equals less than or equal to 16. So we need to grab the boundary line. So this one I'm going to use the x and the y intercept. So when x equals 0, y equals 16. That means I'm going to hit the y-axis at 16, 5, 10, 15, give or take over there. And then when this is plus, when y equals 0, of course, x is also 16. So that would be here. So this will be my first boundary line. And it's, of course, a solid line. Now I need to decide which area I'm going to shade, either quote unquote below, let me just call it the A area or the B area, below or above the line. Of course, for that, we use a test point. We may use 0, 0. So I have 0 plus 0 is that less than or equal to 16. Yes, indeed, that means that 0, 0 is part of the solution. So we'll have to shade the area this way, the A area. I'm not going to do it yet, otherwise it will get kind of messy. Okay, so 1 down, 3 to go. Second, let's see if I can switch course here. So what do I have? 3x plus 6y less than or equal to 60. Again, we need to first grab the boundary line, 3x plus 6y equals 60. And here I can use also the x and the y intercept. When x equals 0, I have that 6y equals 60 divided by 6. Y equals 10, 0, 10. So I'm going to hit the y-axis at 10. This was 16, so this would be 10 here. And then when y equals 0, I have 3x plus 0 equals 60. If I were to divide by 3, over x equals 6 over 3, that would be 20. I'm going to hit the x-axis at 25, 10, 15, 20 right here. So my second boundary line will be a solid line going through these 2 points, which is something like this. Once again, I split the plane in 2. So let's just call this guy A and this guy B. So now we need to go back to the inequality to see which side of the inequality we are in. We can always use the test point. So let's go ahead and use 0, 0. 3 times 0, 0 plus 0. So that is 0 less than or equal to 60. Absolutely, that is also true. That means that 0, 0, the origin is part of the solution. So the red one points to the A region in. Okay. So 2 down, 2 to go. Now the other two are kind of trivial. Let me do it in let's see what I got here. So let's do it in purple, I guess. Yeah, purple. Greater than or equal to 0. Of course, we need to graph the line x equals 0. X equals 0 is, of course, the y-axis, and notice that this one pushes to the right. So the y-axis to the right, we are just only contemplating positive numbers in x. Likewise, y greater than or equal to 0. If I graph the line, graph x, y equals 0, that's my x-axis. Remember, y equals 1, y equals 2, y equals -1, y equals -2, y equals 0 is the x-axis. And then it's greater than or equal to 0, so it points up. Okay, so we are done. So the region, of course, will be this guy here. Notice that x is greater than or equal to 0, y is greater than or equal to 0, is below the red line, this is the red line, because it's less than or equal to 60, and it's also below the black line, which is this guy here, less than or equal to 16. So the intersection point where all the regions meet will be in this area here. Notice that, of course, I cannot shade this guy because this guy satisfies the first one, but not the second. Okay, I cannot shade this region because it satisfies both the black and the red. However, it does not satisfy the last two, so the coordinates must be greater than or equal to 0. I cannot shade this little corner here in the middle. It satisfies the red one, but does not satisfy the black one. So the only intersection would be that corner over there. Okay, and that would be it. You just do one at a time, and then we take the intersection. Let's see if I can find a second example. Let's try another example, folks. I believe this one will be very similar to the one we just did. Notice that I just drew the plane like this, of course, because I already know that my x will be greater than or equal to 0 and the y greater than or equal to 0. So I already have only quadrant 1 available. And I will not be anywhere here, but these two constraints already force me to be in quadrant 1. Both x and y must be positive, greater than or equal to 0. So let's try the other two. So I have I have x plus 2y less than or equal to 12. My boundary line will be a solid line, x plus 2y equals 12. So when x equals 0, I have 0 plus 2y equals 12 divided by 2, y equals 6. So when x equals 0, y will be 6. 1, 2, 3, 4, 5. Give or take over there. And then when y equals 0, x equals 12. Oof. Okay, I'm out of the plane. So let's see, what do I have? X plus 2 times 0 equals 12. X equals 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Give or take over there. So this will be my first boundary line. And now we need to select the test point as always. Go back to the inequality. Let's take 0, 0. 0 plus 0 less than equal to 12. Yeah, so this one will include the origin, so it pushes in. Oh, the right triangle. So let's try the second one. 2x plus y less than or equal to 12. Boundary line, solid line, 2x plus y equals 12. When x equals 0, I have y equals 12. Yes, I'm going to hit y. Now this is out here. Okay, that will be y equals 12. And then here I have 2x plus y equals 12. Now I can make y equals to 0. So 2x equals 12 divided by 2, x equals 6. So 1, 2, 3, 4, 5, 6. So this second inequality looks like this. And of course, I need to test to decide where am I, below or above the line. So for that, I go back to the inequality and I use a test point. I can use 0, 0. 2 times 0 is 0 plus 0. Is that less than or equal to 12? Yes, indeed. This is included, so the red one pushes in as well. And so you can see that the inequality result will be this closed area here. We get the idea. Okay, that's when x greater than or equal to 0, y is greater than or equal to 0, 2x plus y is less than or equal to 12, and this one is the x plus 2y less than or equal to 12. So this will be the intersection. I hope this helps.